Is my screen visible?
Yes, sir.
Okay.
Hello, sir. There is some noise coming from your side.
From my side?
Yes, sir. I guess might.
A lot of noise. Is it okay now?
Yeah, sir. Better.
All right. So we stopped at casts, and I wanted to show you some example where casts would be necessary. But it turns out that the early examples given in this book, I mean, this is a bit outdated, and so casts are basically used to explicitly convert one data, explicitly convert data from one type to other. But so data conversion is kind of relatively implicit data conversion is kind of sketchy in C, but it's not that in C++. And you can actually easily convert the basic data types into one another without using casts. So in this book, in your standard textbook, some early examples were given while where the intermediate, some composite mathematical operations are given, and in the middle you need to convert from one type to the other to facilitate the size of the number being produced. And it was claimed that in such a situation you would have to explicitly use static cast. However, so it turns out that the compiler that you are using now, it kind of takes care of these problems, and at least for numerical data types, it's good if you explicitly mention this what you're converting to, but this kind of in between operation conversions to hold the data, etc. These things are done by the compiler actually automatically. Yeah, so in these cases, static cast is, explicit conversion is not necessary. So, but then still casts are used, and it's, so I'll say that even when you convert between derived data types like pointers, etc., then also it is not it's not necessary to use casts, but sometimes we'll see that they decrease the amount of, they decrease your trouble. They decrease the amount of code that you have to write. So we'll see some examples like this, in which at least static cast makes our life easier. So let's start with data conversion example. Okay. Our favorite distance class. Yes. So I'll not explicitly demonstrate where this is necessary, but yeah. So this example, static cast can be, replaced by conversion where you don't use this operator. This is our favorite class distance, and this is the conversion parameter, or so constant. You can do without writing constant, but this is a parameter that's never. This is a variable which is a conversion parameter and is not going to change in the whole program. So better write constant, just to stop yourself from changing it by mistake. is the one argument constructor here. This is the convert to and this is the individual components. Feet is the integer part and inches is the residue, and go on. This is the so our put list and get list functions are still left. And this is the, it's constant because this is the display function. The fractional part of feet. And it's equal to here the conversion takes place using static cast. This means convert to float. So here it will, it's just a demonstration of the usage, but this will work without static cast as well. Yeah, so this is the conversion to meters. Okay. Our first object of distance is test1 equal to 2.35. Just let me check whether this is all right. Meters. Okay. So this will be. Sorry, this is the. What did I do? does not show list actually. Okay, so display function I've written wrong. Sorry. So, display function. And so this will be, what does it do? So this is the conversion operator. So conversion function. So this should be our. This is our overloaded operator. Better rate conversion operator. Yeah, and this is the equivalent to conversion to float. Yeah. So our usual syntax for overloading is this, and let's see. Keyword spelling is wrong. Yes. Okay then. This is our print function here. Here is distance 2, which should we use the, so this was using the one argument constructor, and here we may use the two argument constructor. Okay, yeah. Let's see how this works. So we have given this distance 1, and yeah. So distance 1 would be 7 feet 8 inches. That is fine, and this is okay. And so for distance 2 we have okay, right. So the program basically converts the fixed float quantity, that is from meters, 2.35 meters, to feet and inches, imperial units, and yes, so basically 1.8 meters or 1.82 meters is roughly equal to 6 feet. So you can 30 centimeter equals to 1 foot, so 2.12 centimeters would equal to 8 feet, and yeah, so around 24 centimeters would equal to 8 inches, so that's all right. And so the other direction, yeah, so distance 1 is here, all right. It is reconverted into this meters again, that's fine. And then we have given distance 2 in the imperial units, 5 foot 10.25 inches, and we have said that this meters equals to distance 2. So that kind of yeah, then it is changed to so 5 foot 10.525 inches is changed into meters, and it becomes 1.78481 meters. Of course, like the opposite thing, so if you want to convert distance to meters, so for meter, like, so converting from distance to meters, we are using the overloaded float operators, and yeah, if we do something like this, obviously it won't work. So if we do something like this 2 equals to meters, then we'll get an error, but yeah, let's see nevertheless. Yeah, it's not working. Okay, good. So these are some simple assignment statements, and so, yeah, let's see another example. Now that we have done numerical example, let's go into strings. We'll see. So this is what we define a string, and here we have private. We should declare the size of the string objects, which will remain unchanged. Yeah. Num size equal to 8. This is our no argument constructor. It's basically the null here. Oops. String copy. So yeah, the reason behind using string.h is so that we have access to these functions. Okay, and the display function. And yeah. So one conversion operator we'll have to overload, that is the okay. So this one, yeah, this one later on you should try to replace the conversion with we'll use static cast, but if you try to replace this with anything else, it will take more work. So here's one utility of static cast where it converts in one line. Okay, so we'll see later on. This is the kind of conversions where that is really helpful. And yeah, so we are overloading this one and yeah. So just in the main function we'll have to use this. Okay, so basically it's the like we are playing between our user-defined string and the inbuilt C string here. So we are using, so no argument is passed, so no argument constructor, and we'll say that char x str and this. So say yeah, let us name Robert 4. So string s2, our second object of string is right. was his name, Haskell Curry or something. Yeah, maybe it's whatever. And here we'll use the conversion operator. In such cases, not using cust will give you some trouble, but you can get around it. But that's I mean, that's not something very straightforward, at least to me. Yeah. Okay, so this is okay. One error is there. 25, so 16. What have I done? Okay, so I guess this will be the yeah. So give an extra semicolon here. Okay, what am I doing wrong here? Have I missed something? String argument constructor. So let me see. What? Oh, I guess okay. This was all right, no? There was no error message the last time. Okay, yeah. Okay, I was overlooking something. Yeah, so this is all right. And yeah, we'll see. So we have this thing. Yeah, so the one argument constructor basically converts a normal string to an object of our string class, and yeah, the one argument one. Yeah. So the string, the C string that is given to it as input, is copied to a new string object, new like our string class object, for which we use the for which we use the string.h string copy function. And yeah, so this is applied when this Professor Haskell Curry, so this Haskell Curry string is created. Okay. The conversion operator is basically it changes the string, like R string type to C string, which is basically an array of characters, and that is where we perform the overloading. All right, so yeah, so this is still like some inbuilt type to one user defined type convention. So let's see one more example like this, like intra-class conversion thing. Excuse me, too much sound. All right. So yeah, so two types of time displays will be, we'll execute conversions between them. This indicates whether it's PM or AM, and int hours. Let's keep it to this. So the no argument constructor is here. This is basically the three argument constructor. Okay, so this was the AM PM thing, and the other one we use is like 1 to 24. So here it is. So that will be 0 to 23, and these will be 0 to 59 and 0 to 59 respectively. So we have public time 24. And this will be, so if hours yeah, so the what we're doing is like we would so if it's like 8 hours, it's displayed usually at as 08, right? So that's what we did above also. So here we'll say Sept 0. This is okay. So yeah, here for hours we don't need to add that. It's conventionally for the AM PM display we don't add extra 0. All right, here it is. The extra 0 is here. Then we can say Sept hours, and then here's the colon. And if basically we'll do the same thing. Okay, this is the display function and it ends here. Okay. Right, so better. I'll just define this outside. And this is in the class time 24. This is here, and that's operator time 12. Constant. So I'll tell you what. Yeah, let's do this. So one conversion I'll show, then maybe we'll discuss the limitations of operator overloading and we'll discuss the keywords explicit mutable. No need to do this in a hurry. So what we have seen till now is basically two types of classes and just the displays we have seen. Yeah. So this is a logical point to stop. Yeah, and we'll continue with this tomorrow. And today in the lab we'll continue with our algebra module. So slowly we are going towards something, and we have learned how to sort a variable that is in product form, and yeah, so we'll proceed from there in the lab. Okay, so I'll see you at 2 o'clock then. Yeah, and one more thing is, please remind me today if I forget to announce in the beginning. Today you may see your marks from the numericals module till 2 weeks before from your TS, and so during the lab you may interact with them. Remind me if I forget to mention this later on. Okay.